Oh yeah, we're gonna start with the video because I think it is easier to show you what they've achieved than try to explain it through words.
Blue Ghost Riders, the path to the stars is no longer limited to nations alone. Firefly is building the road to the next frontier, one mission and one dream at a time. Tonight, we didn't just reach another mission milestone. Together, we created a moment in history.
Chief Engineer on Ops. Y'all select the landing. We're on the moon.
Nice.
It's really incredible. Seeing a moon landing in 4K is an incredible thing. Can you tell us a bit about what your role was on the day and just like the emotions and everything that was going through your head?
Yes, yeah, definitely. Thank you everyone for being here. Thank you for your time attending this talk. So you just saw the video. It still gives me chills to this day, just seeing how we experienced that moment. So I was the flight director for descent and landing. So I had started my shift probably maybe 6 to 4 hours earlier that day. And it's just an amazing moment, right? So you could feel the energy in the room, really, everyone getting excited. As the moments passed, we had a pretty exact timeline with a lot of the communication blackouts. So whenever we couldn't talk to the lander, we would all stand up, stretch our legs, go get a snack, then come back. But as the breaks occurred, right? As we're getting closer, everyone started getting more into it. Everyone started getting more serious about it. So by the time we got to here, everyone's on their A game, fully focused, just looking at every piece of telemetry that you can on your screen. Because unfortunately, we couldn't see it that way, right? When it was happening, we all just saw a bunch of data that told us how we were doing. So it was a pretty great experience.
You'd mentioned there about the communication blackouts. That was just one of the many challenges that you'd faced landing on the moon. Can you talk about some of the challenges that you faced?
Yeah, basically, we had the communication blackouts as our spacecraft was orbiting the moon. It went behind the moon, right? So we couldn't have direct-to-Earth communications with our lander. So they were all planned, but it still kind of makes you nervous. Of you don't know what's happening on that time. So as soon as you get communications back, you're on the edge of your chairs, checking everything, scanning down your screen, and then, okay, we're nominal. Okay, then we just got to focus on what we got to do next. So for the descent preparation, everything was super nominal. It was we always compare it to a simulation. Whenever we think back about it, we all say someone could have just walked into the room and say, "Good job, guys. This was another simulation." It's okay, it's real, right? Did we just do it or was it a sim? Because it was that perfect. It was unreal that it was just we did 500 hours of simulations, so it was just one more of those. It was pretty nice just working all our way into it.
And my favorite thing about this whole thing is that Blue Ghost helps make that easier for those who come next.
Yes.
Can you talk a little bit about the payloads and things that can help with that communication blackout? And
yes, yeah, we basically on this mission had 10 NASA payloads. So as part of our CLIPS mission, that was our main job, right? So we had about a 45-day transit into lunar orbit, then we had some time in lunar orbit, but really our goal was to get on the lunar surface so that we could get those payloads working, right? We had 10 different payloads, many scientific goals. So as soon as we landed, you saw in the video, everyone stood up, they cheered. That was I don't know, a minute, maybe like 30 seconds of the celebration. Right after that, I was on console and we were like, okay, everyone get back into it, open procedure, 1, 2, 3, and then let's get going. Because we needed to start commissioning our spacecraft once we were on the lunar surface and then get started with payload operations. That's when the fun time began, right? That's when we started collecting all the science. For example, one of the payloads that we had was a drill. So one of the operations involved us in enabling that payload to start operating and start drilling on the lunar surface. So this is one of the first robotic drills that have operated on the lunar surface for this long and has gone as deep. There was another payload that is like trying to develop the technology to repel lunar dust. So you can see in the videos that we took, like you can see it's a little piece of glass. It's like maybe not bigger than this. And then you can see it like all covered with the lunar dust. You saw our landing. You saw a few rocks flying around. But then we enabled that experiment, and then it repelled all the dust. And then another big one that I want to talk about is basically when you are attempting all of this to land on the moon, there's no GPS, right? So on Earth orbit, a lot of our satellites navigate just like we do our cars with the GPS signal. But on the moon, there's nothing like that. So one of our experiments was trying to develop a receiver that would be sensitive enough to read those GPS signals in lunar orbit, and they were successful. So they broke the record for the furthest distance just in orbit and then on the lunar surface as well.
I loved reading about that. Like, we have all these GPS satellites orbiting our planet all the time, but they're all facing their power down towards the Earth. But a little bit of it sneaks out into space, and you can use that power, and you manage to...
Yes.
Were you the first to do that?
Yeah, that was the lunar payload. They had a provider from the Italian Space Agency and a provider like an Italian company, and they were the first ones to have gotten a signal that far outside of Earth, like you're saying, because all the signals are pointed at Earth, but you can get some of the signals outside.
Incredible. It's like stealing your neighbor's Wi-Fi signal.
Exactly,
It's great.
yeah, just like that.
You mentioned the lunar reglet too, and you can see it in the landing footage, and that's one of the big challenges too, that Blue Ghost uses a visual, what's the 3 words? Visual navigation system?
Yeah, vision navigation system.
Yeah, and you're using cameras for that. It uses maps from the moon that we scanned years ago to identify the craters and figure out where it was. But as soon as you get closer to the ground and everything gets occluded by the dust, nothing works, right?
Right, yeah. So the technology is our vision navigation system. So for us to navigate, because there's no GPS signal, we got to rely on, you can literally think of this as a map of the moon, right? Made out of just pictures. So this is something that NASA has been developing with the Lunar Reconnaissance Orbiter. So we communicate on them a lot to start building the maps, to start building our landing corridor. So if you think about like an airplane as it's taxiing, like, or preparing to land, right? Not taxiing, it has those maps and it knows its approach, and it knows how it has to be lined up. So we work the same type of deal with NASA, where they would, every time their LRO was hovering over our landing site, they will take more images, right? Try to get us more data. And that's how we started building our maps. So whenever we were in that room, in the control room, and we were getting ready for this, we knew this is our last approach, right? As we're orbiting, we're basically kind of getting closer and closer and closer until like that last orbit, we're basically going for it. So that's when we leverage all the maps, when our vision navigation system is basically guiding the lander to its final spot. We in the control room just basically give it the last green light, and then everyone's hands off. So everyone was go for descent, and then from that moment on, we didn't do anything other than watch the data. And then the lander with the vision navigation system made all the decisions. During our descent, we actually had 2 times when our vision navigation system decided there were too many hazards, and then it replanned to another spot. And then, like, that was one time, right? And then it saw that it wasn't perfect again, and then it tried again. So it did it all by its own until it landed, as you saw in the video.
One of the things that blew my mind when I visited Firefly and just learning how difficult it is to land on the moon was just like, it's hard to even know whether you've landed or not, right?
Yes.
How did you figure that out?
Yeah, so basically we had only the data, right, from the vehicle. That's the only thing that can tell us. if we landed or not. So on our lander, we put 4 contact sensors, like one on each of the legs. So we knew for sure, like something must happen that indicates that this has touched the ground in some way, right? So this can just give you contact. It could have been a rough contact, could have been a soft contact, but we had that one indication. And then we have an altimeter as well. So as we're sitting all in the room, just in silence, watching the screens, we can see the data of it like coming down, right? But there's craters, so there's a little bit of variation. But that was the exciting moment when you saw our chief engineer call out that we had a successful landing. He had like basically like maybe like 8 or more pieces of data that had to be put together to say, we did it, right? This is it. So after he called that out, everyone celebrated. I just kept looking at the screen. Is it real? Did we achieve all 8 of them? And it was true. And so that's what told us we were successfully soft landed on the lunar surface.
I remember Will Coogan was telling me about the actual landing leg sensors. They're literally just a cable that unplugs because the foot just gets shunted a little bit.
Basically, our landing feet are like a giant wok, if you think about that, right? So it's a big dish, and it was like in a certain position all through the launch, all through the transit. So when we landed, it basically had like a wire on it. So when the ground like rotated the dish to be contacting the surface, it broke a wire. So that was like a super simple way that would tell us is like, okay, something happened where now our legs are like in a landing position.
Yeah, I was blown away by just how simple that solution was.
Yeah, it was a pretty elegant, pretty like, yeah, it makes sense.
I feel like if I came up with that on the job, I'd get shouted at for being too simple. And obviously, like, it's amazing that you landed on the moon, the technologies that you've developed and everything, the engineering, but like, why? Why are we going to the moon? Why do humans want to go up there?
Yes. Yeah, so basically, just to put it in Firefly's perspective, so we are one of the companies that are participating in CLPS, Commercial Lunar Payload Services. So the real goal of this is for us to take payloads to the moon that are going to gather the science, the data that is needed to enable the human missions, right? We just saw Vanessa talk about Artemis. So we are trying to get all the data that's going to help them. If you think about the Apollo missions, the longest Apollo mission was 3 days and 3 hours on the surface. Out of those 3 days and 3 hours, it was like something like 22 hours where the astronauts were actually outside of the lunar module. That's just 22 hours of data that they themselves could gather, right? Our lunar mission, Blue Ghost Mission 1, actually did like more than 14 days of surface operations. So imagine we get all the science experiments that NASA needs to enable the human exploration, human occupation of the moon, then we can get a lot more data. And that's just one mission. And there's many providers, many more missions that we can do. So that would just give us a lot of data that would enable the humans to be there safely and then to be there for the long haul.
And isn't Blue Ghost 1 had the communication node on board, right? So it can help relay information around the moon?
This was just a direct to Earth from our lunar lander down to the ground stations on the Earth. Starting with Blue Ghost Mission 2, and we got right now Blue Ghost Mission 2, 3, and 4, we have a double stack. So we're going to take an orbiter and we're going to take a lander. So from now on, every mission that we execute is going to have 2 vehicles, and then the orbiter can function as a relay. So as we're building this you kind of call it a network around the moon, we can do relay communications, and we can also do imaging. Just as we had LRO give us a lot of that good surface data, we can start providing data with higher fidelity and better sensors than LRO in the upcoming missions.
So that's obviously a big part of Firefly's role on the moon, is building out that infrastructure that will allow the Artemis program to land and humans to land again. What's next for Firefly in building out that infrastructure?
What's next for Firefly? So I think I see Firefly as a big enabler of just getting there reliably, right? Just as today you can think about SpaceX as like, oh, it takes nothing. Like SpaceX sends like, I don't know, 100 rockets, right? And like it's no big deal. I see Firefly taking that spot for the lunar economy, right? It's like, oh, you need something taken to the moon? Yeah, let's go. We can do it like we were saying, like right now we have once a year, and then the Jared wants lunar missions once a month, it's like, okay, we're on board with that. So I think Firefly can be a big enabler of doing that reliably and safely.
And what's the big milestone, next big milestone for you?
Yes. Personally, or like for our missions?
Why not
Or
both?
both. Okay, so for the company, our Blue Ghost Mission 2 is going to be the first American mission to go to the far side of the moon, right? So our next try is not going to be as easy. I was just chatting with Ryan, and we were saying maybe it's like 5 or more times as difficult as our first mission, right? We not only have one lander, we have 2 vehicles. We have to do a relay because we're not going to have direct to Earth for the landing. And we're going to be like in an area that no other American company has gone before, right? So that's like the next challenge. And then as we keep working, we are trying to build our infrastructure for repeatable and scalable capabilities. The fact that we did Blue Ghost Mission 1 is great, right? But if we cannot make it easier every time, it does nothing, right? We got to make it easier. We got to make it safer every time. And then personally, it's just trying to get ahead of all those problems, right? Trying to make sure that I am in front of the curve, that I am trying to have that vision of scalability and sustainability. We don't want to have, let's say, in 2029, 6 vehicles or like 5 vehicles that are going to be in orbit, and my team is going to be 100 people, right? That's not sustainable. So it's just also the human aspect. How can we help everyone not have to be on console 24/7? How can we automate things? How can we make it more convenient for our people on Earth as well? Yeah.
And I'd love to talk to you a bit more about your own background too. You've managed to land a job, one of the most difficult jobs to land as someone who was not born in America. The barriers to entry here are so big. How did you overcome that?
Yeah, so one quick clarification. I was born in the U.S., but I lived in Mexico from basically when I was born until I was 16 years old. So one of the big barriers was like, okay, at 16 years old, like going to high school in the U.S. is like, okay, this is completely new. But I think one of the beauties of engineering is like, if you know the technical knowledge, that's a universal language, right? So everything that I learned in Mexico, I would come to the U.S. and it's like, okay, now I just gotta like think about this. What is the English word for this? How do I like translate my knowledge? And that helped a lot. So that helped me progress a lot, like catch up in all the classes that I needed to take. Like one of my nice stories to say is like I went to a teacher because I didn't want to take geometry because that was boring. And I was like, oh, there's this thing called credit by exam. Can you like sign my paper? And she just looked at me weird and she's like, you want to take like geometry credit by exam? It's like, no one has ever done that. It's like, so? It's like, I want to do it. So she signed the paper and she's like, good luck, you're not going to make it. And then I showed up next time and she's like, oh, you actually did it. And then that was my experience, right? I knew a lot of the technical content. Now I just needed to like relearn it in English. And then from then on, it seemed like, okay, there's all these challenges. You just got to tackle them. You just got to go, okay, what's the next thing that I want to be working on? And try it out. Like that was like going to UT, working in Houston, then coming back here to say, can I do like things in like for lunar missions? I think I can. So just try it out.
Yeah. What did you study in UT?
What was that?
What did you study?
I studied aerospace engineering here at the University of Texas.
Would you give anyone advice on how to like follow your career path?
I think one of the biggest things that I learned at the University of Texas was not only like being aerospace, right? That's your career path, like what you're studying. That's all put in front of you. But something that's not put in front of you is the opportunities that you want to take outside of that, right? Everyone can graduate with a degree, but what else are you doing? So one of the things that I really liked was the Texas Spacecraft Laboratory. So it was a lab that we had at UT where you get to work hands-on with CubeSats. So these like little tiny spacecraft. So that was a game changer for me. That really showed me, okay, I'm really passionate about this. I'm good with my hands. I can put this together. So starting from the basics of how does this structure get fabricated to how can I make this lunar lander like operate in lunar orbit on the lunar surface, I think it's like you go up, right? So you start learning your basics. I don't think you can ever get to a super complicated operation if you don't know the basics. So I think that's my lesson. Like, you gotta work your way up, you gotta learn the basics, and then that will give you everything that you need to keep going up.
I agree with that 100%. What was your favorite? I skipped over this question earlier on, but like there's so much scientific payloads on the Blue Ghost 2. Have you discovered anything new? Is there any new like little unexpected discoveries that you've made through the payload so far that you can speak about?
Yeah, I think my biggest comment on that was that some of the payloads, as they are processing their data, they're making it public, right? So for example, this GPS payload, like a lot of their data has been put out there. So like other people can also like go through it, process it, see if they draw some different insights. Because I think that's really valuable in everyone putting in their own perspective, everyone contributing via their own background. So I think by making that data like accessible for a lot of people, I think we can get a lot more insights than if it was just contained to a few.
And do you think Firefly's missions are helping humans land on the moon in future too?
Yes, yeah, we have done a few conversations with some of the other companies that are doing this, just so that we can all learn, right? Just as we have other companies that have different data, we have other sets of data. So just collaborating, thinking about the lunars getting to the, about the humans getting to the moon as the ultimate goal, then you start feeling like, okay, yeah, this is what we're all in for. So this is not like, oh, Firefly needs to land, or iSpace needs to land, or other companies needs to land. We all need to enable that to go forward. Because if you think about just CLIPS as a program, if we're not all successful, then there's not going to be a lot of incentive for the government to keep funding this.
Why do you think humans should go to the moon? Like obviously there's all these resources and everything up there, and like I'm dreaming of having like on orbit manufacturing around the moon and everything. Why do you think we should go up?
So this is going to be a really funny story. So you probably have all seen the movie Moana, right? Raise your hand, maybe. Yes, you're nodding. Okay, so what does she say? We're explorers, right? That's why she wants to go out of her island. So I think it's the same thing for humans. It's like, why did we discover the new continent? Why do we keep like pushing? Because we're explorers. So I think that's our ultimate goal. Like, we got to keep exploring. And we see the moon, you go out at night, like that's right there in front of your face. So I think that makes it very clear and unites us all. Like we can all go out and see the moon. So it's like, that's a perfect goal, I think, for exploring.
Yeah, I couldn't agree more with that. I think we need challenges.
Yes.
We need more challenges that are good for the world. We were going to open up up to questions from the audience if anyone wanted to ask anything.
Yes.
Should we pass around mics or should we just stand up?
Thank you. I think every time I hear a conversation about developing the moon, somebody always talks about how awful moon dust is and how antagonistic it is to all mechanical items. And is that true? And if so, how do you manage that going forward at scale?
Can you repeat the middle portion? Something about all being mechanical?
Just that moon dust in particular.
Okay.
It's very crystalline. It's very damaging to mechanical
Yes.
parts. How do you deal with that?
So it's very abrasive, right? So for the crew, that's a really big problem. So that's why we had that experiment that was trying to develop technology to repel that dust. So that helps with the crew approach, and that helps with radiators. For example, on our mission, as we landed, like all the dust that we kicked up landed on our radiators, right? So that affects your thermal environment, your capability to produce power if it lands on your solar panels. So that's where it becomes a problem just for even for the robotic missions, right? So that's where technologies that repel the dust, technologies that are more resistant to just having that dust be on them, right? That's where it becomes really relevant. So I don't think we would enable sustainable presence if we don't learn more about the lunar dust and how to get like through it.
Hi, Marcus Harvey. The question with regards to surviving the lunar night, what kind of technologies are you thinking about there? And I suspect it would be the same on the far side of the moon. Is that correct?
So surviving the lunar night. Our Blue Ghost Mission 1 survived 5 hours into the lunar night. And then we also were very lucky to have a solar eclipse while we were on the lunar surface. So our mission gathered a lot of data of what does it look like when you're in the nighttime, right? So we had like 2 hours of totality for the eclipse. So that was a really nice way to say, oh, what is it the nighttime like without having to commit to a full nighttime? And then the 5 hours that we operated, we gathered all the data of how our systems were being affected basically every hour of that. So how are we preparing for the future? So we have yet to face a mission that requires us to survive the lunar night. On the far side of the moon, we still get sunlight, right? So when you see a new moon here on Earth, it's basically full moon on the far side. So we would experience the same kind of timeline where we see the 14 days of lunar day on the far side of the moon. But eventually, we're looking into how can we interpret all that data to start developing a system that can survive the lunar night. That could be nuclear for your heater power, or it could be just isolating your core system. So everything that you need to survive, put it in a nice, like, cozy area, right? That you can have batteries to keep it warm for that time frame. And then once that you come back, like, you can turn it on again. Yeah.
Hello. So my question is, in the last 10 or 15 years, we all know that we want to go to Mars because this one guy has a dream about it, but we were on the moon like kind of 50 years ago. So what happened in the middle? Why we kind of lost interest in the moon for a while?
So you can think about the Apollo missions, right? It took a lot of money. If you think about a Saturn V launch in terms of today's money, it's like about $1 billion, right? That is way more than it took to do Blue Ghost Mission 1. Also, the time frames have changed a lot. So with the commercial approach, you can not only like do it for cheaper, but you can do it faster. So I think that's what changed recently is like, hey, we're proving that it doesn't take a whole nation to do this, right? It takes like companies and it takes this much amount of money to do it. Like you saw the Artemis Accords image, right? It was 61 nations behind it. Think about the Apollo era. It was like the U.S. behind it. So I think that's why the moon seems like way more approachable right now. It's not only nations, groups of nations, and private companies that can do it. So I think that just changes the whole perspective and the economics for it.
Thank you.
What techniques did you use to develop and test your autonomous controls?
What techniques did we use to develop our thermal controls?
Autonomous.
The timers?
Like the autonomous controls?
Autonomous controls, yes. So we have, as part of Firefly, obviously we make rockets, right? So we have a place called Rocket Ranch. That's a 200-acre like facility. As part of those 200 acres, we made a lunar landscape. So if you look at Google Maps, you can maybe kind of see it, but it's been like overtook now by grass and like weeds. But we developed like a lunar landscape, and then we put our instruments and our basically the logic of our vision system on a drone. So we flew it, and then that kind of validated a lot of the algorithms that we used to build that navigation system. So that was like a more like human way to understand it. You're flying it, you're seeing the terrain, you see the craters, you see how to navigate around it. But also there's a lot of simulations, just software simulations. So there were like many simulations. As we were getting ready to land, there were simulations being run like ahead of that, right? So that's for the systems, for the people. So my job as mission operations is to make sure that the team is also ready to do it. So we actually, while we were flying the mission, we did 2 simulations with the team that was going to be there that night to see if we could all be like successful, right? Since the launch to whenever we were going to do the landing, a lot of time passed, right? So maybe you forgot, maybe you weren't as sharp on the procedure that it took to land on the surface. So that's why we did 2 more runs, like maybe a week ahead of our actual lunar landing. So we had a lot of confidence in the operators, and we had a lot of confidence in the technology.
Thank you.
So for Blue Ghost 2, I know this is kind of like asking about your favorite child, but what experiment are you most excited for? And this can be for Brian too, if you have an answer.
For Blue Goose Mission 2, we are now taking commercial payloads. So that is a big difference from Mission 1. So I would have to go with the rover that the UAE is flying with us, right? That's going to be like interesting. It's a very interesting dynamic. Now we are working with a commercial payload provider, not a NASA payload. And they also have like a very unique system. So it's the first rover that we're going to fly. So I think that makes it pretty interesting as far as the payloads go.
You stole my one. Vehicles within vehicles.
Yes.
Top notch. Favorite thing every time. I think honestly the GPS, deleting the GPS off Earth and payload, I think that's just incredibly useful and cool.
Yeah, that's pretty cool.
Speaking of GPS, are there plans to put an actual GPS system in lunar orbit so that they don't have to rely on Earth satellite
Yeah.
data leaks to get there?
That's a good question. As far as Firefly goes, not really, right? Our main focus right now are on communication relays and then lunar mapping. But I think that's a great idea. We should tell that to our business department to start working on it.
So for that GPS, do we already have capabilities with the satellites we have now that can actually do and help with that navigation piece?
Basically, yeah, that's what this experiment proved. It was a very sensitive, basically GPS antenna that was trying to capture those signals. In lunar orbit, it took special pointing operations, but they proved the concept. So I think going forward, that gives them a lot of data of like, how can we enable this without having to be a special system, right? Like having to point us in a different direction or having to like do these special things. How can they start evolving that technology so it's just now works, right? You don't have to do anything special for it. But they proved that, like we can get GPS signals around the moon that could help you land like in the future.
Hi. As Director of Operations, what engineering challenges do you foresee there being as Firefly tries to scale?
During mission operations?
Yeah.
So during mission 1, a lot of the challenges where we're a very young team, we're a very young company. So a lot of the people that were in that room, it was basically the first spacecraft that they have ever operated. So one of the challenges was to make sure that we could all get together, get on the same page, how we need to behave, how we need to like keep our minds focused so we can execute. Going forward, so mission 2 is going to have 2 vehicles. So now it's not going to be like, okay, we're all the same team. Whoever needs to help, come over. Now we got to multiply that times 2. And we're not going to have a team that's just multiplied times 2, right? So we're going to have to be able to be smarter about how we operate it and then focus the resources wherever they are needed. Like that's going to be a big challenge. It's like how we had one team before, it now has to be 2 teams, but you don't get twice the people. Yeah.
This is more of a like fly and forget sort of a mission, right? Like it's just there, you can't fix it, you can't repair it. So what kind of redundancies or like fail safes do you plan when you are designing a mission which is going to land on moon?
So what kind of redundancies are baked into our system, right? So I would say it's a very different approach. If you think about a human system, it has to work, right? So there has to be like maybe 2, 3, maybe even 4 redundant levels because you want to keep the crew safe. So on our robotic vehicle, you get a little bit more liberty with that, right? You don't have stringent rules that you have to comply with. So we optimize. Where do we actually need redundancy? Otherwise, it's just one system and that's it. So it's really like on a case-by-case basis. But for example, on our vision navigation system, you could think that we had like twice the cameras that we needed. That was not the case. We had like a set of cameras. One was looking like down, like if you imagine the lander standing in front of you, one was looking down and one was looking at you because that's what was needed. Mass is at a premium, right? Power is at a premium, so you got to be really smart on your redundancy.
Another question, sorry. So without any hype, how far you think we are from actually living on the moon?
How far were we from the target?
Yeah.
Yeah. So if you think about where we're standing right now, maybe think about 2 blocks that way. That's how far we were from the actual like very specific point that we could target. Oh, in years?
How far away are humans from living on the moon?
Oh, how far away? We just saw it, right? We saw Vanessa's answer, like 2027, 2028. So I believe that, right? We just gotta, like I said, we gotta be really smart about how we make those decisions. And I think the new administration has put all their support behind that. Like you saw, like we're talking about today, is the moon the new Mars? Yes, because we need to show that we can get to the moon, that we can operate reliably, and then we can go to the next level. So I think we're there. Like, it's just exciting to know that in our lifetime, we're going to be able to see that presence, and then we're going to be able to see the presence on Mars.
One last question. For the roadmap, when will you actually launch and land with just Firefly technology? And will that be from Vandenberg or Wallops, or what is your vision on that? When will we be able to see that end-to-end mission like that?
Yes, so in terms of years, our mission 2 is no earlier than 2027, our mission 3 is 2028, and our mission 4 is 2029. So that kind of gives you a perspective. And then in terms of like launching, right now our missions are launched on a SpaceX vehicle, but Firefly is also working on a vehicle called Eclipse that has the possibility to take our landers. So if you think about maybe mission 4 or maybe further in the future, so 2030, let's say, as early as 2030, we could be launching our own lunar lander, so then it will be a fully vertical company.
I think we have time for one more question before Scott Manley takes the stage.
Anyone?
Right? No? All right, Scott,
got
I think
them
you're
all.
up.
Yeah, thank you, everyone. Thank you for being here.